Okay, so we are told that a right circular cone has a volume of 13,200 pi cubic units. For this cone's circular base, we're told that its circumference is n units and its area is 30 n units. We're being asked for the slant height of the cone. Now this immediately stands out to me because this is certainly not the same thing as just seeing the word height of the cone. And I'd first like to talk about the difference. So let's say that I draw a cone here. I'm not saying this will be the exact dimensions of our cone here, but I want to get an idea of how the regular height and slant height relate. When we say height, we're talking about beginning at the very top of the cone, but going down, straight down in fact, to the center of the circle. Now, when we say slant height, we're talking about, well, still starting at the top of the cone, but this time we're going to go down in this sort of slanted fashion and then reach a point on the circumference of the circle. And if I add a little bit more, we're going to notice what's going to happen here. I'm going to call the height that I originally drew h, and I'm going to call this over here the slant height with the letter, let's say, S. Now, because this is specifically a right circular cone, I can definitely ensure that these two things are perpendicular, they form a right angle, and I might now notice, well, wait a minute, it seems like the thing sort of that connects these two heights at the bottom is the radius. And I see a right triangle kind of construction here, so I could say that perhaps h squared plus r squared is equal to s squared. So if I want to solve for s, I would take the square root on both sides, and in this particular case, we're going to disregard the negative square root and the plus or minus because we're talking about something with positive length. So it seems like if I can find the height and the radius of this cone, then we can get our answer to the question through this formula. Let's see if we can do that. Well, I see the n and 30n. I'm not sure exactly what to do with that just yet. Perhaps I'll start with the volume here. Well, the volume is equal to this number, and if we look up the formula for a cone, we're going to see that the formula for that is 1/3 pi r squared h. So it looks a lot like the formula for the volume of a cylinder, but you have that 1/3 out in front. In this particular case, I might notice that the pi's are going to cancel. If I multiply both sides by 3 to maybe change this 1/3, I get a 39,600 equals r squared times h. And this is progress, but it's not enough. I don't have the ability to solve for r or h just yet, so now I'm going to have to figure out a way to talk about the circumference and the area. But now one thing that I do notice is that the n there is just a constant. What this is really trying to tell me up here in the question is that the area is 30 times more than the circumference. So if I disregard the units, I could simply try to argue the area is 30 times the circumference. A lot of students tend to, look at random variables thrown into the question and panic a little bit because that means they have more things to look at. But in this case, I found a great way to eliminate one of those variables and now hopefully have an equation I can use a little bit easier. The area for a cone circular base, so that's just a circle. Pi r squared would be the area of that. The circumference of a circle is 2 pi r. And if I simplify this, I'm going to get 60 pi r. And that would mean that the pi's cancel again. The radius here cancels, and one of the radii there cancels. That leaves me with r is equal to 60. Once I have this, I can now back solve into this. So h would be equal to just dividing by r squared over r squared, but that's just 60 squared. If you put that into a calculator, you're going to get 11. With all of that, I now have everything I need to find the slant height. This would just be 11 squared plus 60 squared. And if you put that in a calculator, you're going to get the nice answer of 61.